Okay, we're back. So over the break, I was trying to get everything to run from Maven to do a clean verify, and I was having problems. It was running the unit tests okay. I deleted a bunch of stuff so the unit test wouldn't fail. But then when you run the integration tests, what Maven does is it starts up Jetty, and then it runs the integration tests, and then it shuts down Jetty, and then it sees if anything's failed. When it starts up Jetty, there's some configuration in the POM. That does the following. It basically says, hey, start up Jetty and wait for, and keep pinging a URL until the URL responds. And the URL that's configured to look at is just /appointments. So what was happening, and so I was like, great, it's sitting there pinging /appointments, waiting for it to respond. Unfortunately, what happened is the way that I had currently implemented the appointment book servlet is that if it just hits /appointments, there's no owner, so owner is null, then you get a null appointment book. He ends up passing it down to pretty print. Appointment book is null. You try to get you try to send a null book to your pretty printer, and you get a null pointer exception. And so it was never starting up. It was actually timing out after those 20 seconds. And then like nothing was running. It's like, that was really bad. So and by the way, this worked fine in the toy project because /appointments is a perfectly valid URL in the toy project. So what I did to get around it is that I just go back to my servlet here. I just implemented, just sort of put in the shim of saying, hey, if owner equals null, just send back error code 200, say it's okay. I don't think I test your code without an owner, so I think it'll be okay for you to do this too. But if you're trying to run the integration tests from Maven and you're seeing something like that, this is how you get around it. It's basically saying, hey, I'm pinging the URL, waiting for you to wake up, or waiting for you to start up, and every time you're pinging it, it like blows up and gets this error. And so it's like, hey, obviously your web application isn't ready yet. So anyway, something that I learned. So now I will commit it and push it. Oops.
So you're going to test the command line?
I'm going to test both the command line application, so your project 4 main, and then I'm also going to hit that first URL with wget to just hit the Jetty directly. Surprise! Yeah. Thanks for coming to class. Look at all the good stuff you learned. Okay. Got the automated tests working again, I hope. We'll find out. I'll commit and push and see if I get a nasty gram from my continuous integration server saying, hey, what you did didn't work. Yeah?
When you run your integration tests in Maven, does it run each test as if it's starting back from 0, or do they build on each other?
Very good question. So the way Maven works is that you start up the answer your question. Yes, all of the integration tests are run in the same JVM. It doesn't restart Tomcat every time. So yeah, you have to be careful because there are side effects from each of your tests. Normally, unit tests are not supposed to have any side effects. They sort of like do their thing in nice isolation. And unit tests, that's the right thing to do. Integration tests, it might be that you want to have sort of step 1, step 2, step 3. And actually, I think I've deleted all this stuff now. But if you go back to like what's created by the archetype, the integration tests have this like annotation on the class, which is something about run in a fixed order or something like that, and that's why they're all called like test 0, test 1, test 2, so that you get them run all in the same order. So yeah, good question. But it is, here again, this is what it gets a little more complicated now, right? Because you've got you've got two JVMs, one of which is persistent, and then the other one which is well, I guess one is persistent, and the other one is just long-lived and runs all the tests. Okay, so in Project 4, you begin your odyssey of web application development looking at REST. So you've got a servlet, you've got a web container, you've got a Java web application that has URLs, and you've implemented a servlet to handle that URL and just send text back. And this is pretty cool, right? Because you can write a Java client that talks to all of this. And this is one flavor of the web, right? REST-based APIs, very, very nice. You can do a lot with them. Important thing to learn. But the real web is about writing user interfaces, something that's rich, right? You've got this browser, got all this functionality in it. Let's take advantage of it. Let's have something rich. And that's what Project 5 is all about. So we'll get rid of that guy. Okay, so Project 5. Oh, it's tonight. So a little bit of history first. Web browsers have been around for 2016, 20 plus, a little over 20 years now. And what web browsers do is they render something called HTML, the hypertext markup language, into something that a human can read, right? This is like all familiar to you, I hope, at least conceptually. And over the years, web browsers have been able to do more and more and more. And one of the reasons that web browsers have been able to do more and more and more is that, well, the devices that they run on got more powerful, right? It went from running on, your Pentium 1, on your PC or your very old Macintosh to being able to run on faster and faster machines, and now on smaller devices, on handhelds, all that good stuff. And so then web applications have been able to grow up there. Also, another really important thing is that the network has gotten much faster, right? No more dial-up modems, nothing like that. Where it used to be, and if you look at sort of the early web, the pages were very static because they had to be small, had to be measured in, sub-kilobytes in some seconds, because in some circumstances, because otherwise the experience would be just really awful waiting for things to download. So, now, if you sort of look at the evolution of web browsers and stuff, it went from just displaying static HTML, and then there was like that whole dynamic HTML thing where you had language like JavaScript or VBScript and IE, where now there was more, there was like this programming language that was there in your browser, and you could interact with the objects, and so you could do things like have expandos on the screen. You could have like scrolly text on the bottom, and we all thought we were going to be millionaires because we knew HTML and JavaScript, right? Okay, it was the 90s, and so but the browsers kept growing more and more. And then there were sort of like these quantum leaps in what you could do, or what people realized they could do with the browsers, and one of those was Google Maps. Right, and so some of you probably remember MapQuest in 1999, and that was really cool. But boy, was it static, right? You search for a place and gave you this big picture, and then you wanted to click on some place, and then the whole thing had to reload. And then Google Maps came out, and everybody's like, wow, that's kind of some crazy Flash plugin. Let me view the source, and they're like, that's JavaScript, and that's HTML. How did they do all of that? So it was the browsers could handle a lot more. JavaScript was much more rich. But there was another component that really enabled this rich internet application. So as I said back in the old days, web pages, basically when you wanted to go from one place to another, you had a hyperlink, so you click on something and a new page loads. Or you had a form where you enter some information and you click submit and the whole page reloads, because all you had was the get and the post back to the server, and then the server returned you something, and the whole page had to reload in order to do this. Well, somewhere along the way, probably in the early 2000s, the browsers started supporting something called the XML HTTP request object, which is a JavaScript object which lets you make a call back to the server without the whole page reloading. Right, and so now you could do things like, okay, I've got a form on my page, and I will, enter in a zip code or a phone number, and then I've got JavaScript that will detect. It's like, oh, look, the form field for the phone number has lost keyboard focus. You can catch that event inside the browser and say, okay, get that phone number that someone just entered, call back to the server to, that's a bad example, call back to the server to validate it, which you really wouldn't do. You'd probably want to do it in the browser. So let's have another, okay, here's another better example. You're creating a new user account, you want to enter in your username, and you want to let the user know as soon as possible whether or not their username has already been taken. So you can now, so with the XHR, the XML HTTP request object, you can get that username that they just entered, make a call back to the server, validate it against all the other usernames that are out there, and tell the user whether or not that username is already taken. And you can do things like make the box red, or you can pop up a little thing. But all this is on the client side. And you can do it without reloading the page. And as a result, we could, for the first time, have an experience in the web browser that was just as rich as what you get in a native application. Right, because over time they had built up all of the functionality that you needed. You have a rich and beautiful widget set there. You have the ability to do styling with CSS. You have the ability to implement logic. Really, JavaScript's turn complete. You implement anything that you want there running in the browser, and now you can make these remote calls back to the server to get data that only resides in the server, or to do some really heavy lifting or whatever. You can interact with it just like you're using a thick client-server application. And this really changed things. It made it so that you can have really, really cool stuff with HTML. And of course, then afterwards, there's and now there's way awesome, better integration with video. There's the HTML5s, where all sorts of great standards, and of course, there's all the layout and CSS and everything like that. There are a couple of downsides though, which was that back in the day, browsers were really, really different, and so there are all of these like trollish people that know all of the crazy inside and outs of how to do JavaScript for Internet Explorer version 8 from 2001 and everything like that, and so it made it really so to build a website that was both rich and consumable by your entire audience, because let's face it, if you're Amazon.com, your lowest common denominator is, well, I don't want to stereotype, but it's somebody's grandma in the Midwest, right? You know the kind of user I'm talking about, right? So an unsophisticated user that has probably a slow machine, a slow connection, back when they had slow connections, and so you had to handle, you wanted to be able to serve that user, and then also someone who was on the bleeding edge of technology, because they're both your customers. You want to be able to sell to both of them. And so in order to serve these, in order to develop an application that could serve all these customers, you had to have all this knowledge about HTML, about JavaScript, about CSS, about all the different browsers, and it was a pain. Okay. And it was expensive. It was, in some cases, prohibitively expensive. So, smaller shops either had to have websites that were broken on some web browsers, or had to hire a lot of people at very high salaries that knew all this, all these arcane details. Well, enter Google, which has more money than God. They said, okay, great, this is a problem. We want to be able to solve it, and we want to be able to solve this problem of cross-browser compatibility. And we want to have super, super efficient JavaScript, because JavaScript used to be pretty slow, and you can still write some pretty slow JavaScript. But they wanted to have JavaScript that not only ran really fast, but was and potentially optimized for individual browsers, but then also was super compact, so that you sent stuff down. So when stuff went over the wire, you could have lots of functionality, but without having to wait a long time for things to download. And they had all these Java programmers that were good backend developers and just good developers in general, and they didn't really want to have to train them all on JavaScript and CSS and HTML. So they said, okay, we will put. So they wrote this tool called Google Web Toolkit, which allows you to implement a rich internet application that runs in your browser using mostly Java. So all of the logic, instead of being written in JavaScript, is written in Java. All the stuff for doing layout and styling, a lot of it can be written in Java and not CSS and HTML. And so then when this hit back in, it's probably, God, it couldn't possibly be 10 years ago. Yeah, I'll say 2007, 8? Where was I working at the time? 2007, yeah. It was really kind of cool and really kind of interesting, and it's they do some kind of crazy stuff, which I think makes it kind of fun to use in an academic setting. In that they have a special compiler that takes Java source code and compiles it into JavaScript, highly optimized JavaScript that can run in your browser and can do all of this stuff. And why it's appropriate for this class is the following. I've always had a GUI project in here. In the early days, it was like AWT and Swing, and for a while, I've been using Google Web Toolkit because it allows you to write, a rich user interface using Java. This class is only 8 weeks. I couldn't teach you enough JavaScript and HTML for you to like really get something out of it, but with this you can, or at least I hope you can. Lots of students have gone through this. You can. But just like you saw in Project 4, that there's some stuff to ramp up on. There's definitely stuff to ramp up on Google Web Toolkit. So I'll go through the assignment tonight. There is an archetype. I'll show you what the archetype can do, and then next week I'll let you focus on your Project 4, and then in class what we'll do is we'll go into some of the details of what's there in the archetype and how to work with it. Yes, question.
So is the GWT, is that like doing the HTML, CSS under the hood, but we're programming it in Java?
There is the code base that you have has a little bit of HTML. You sort of need like a page to get started, and then the rest of it is Java code that basically will create UI widgets and containers and stuff like that, and lay everything out, and then also implement all of the logic of what happens when I click this button. Oh, where do I get this information? I get this information from this text field. Good stuff like that. Okay. So the final phase of your appointment book project is to write a rich internet application using Google Web Toolkit. And so then what I hope you get out of this is, well, first of all, having fun writing web-based user interfaces. I like writing GUIs. I guess I had the fortunate experience back in 1996 of taking. My college actually offered a class in GUI development. It was like unheard of at the time, and it's still unheard of, right? No one uses GUI. No one needs to know how to use that. That's easy. Well, try doing it. It's not that easy. And we were working back on like the Win32 API, like Windows 3.1. It was pretty crazy, but it was gosh, it felt like real programming. It was like, wow, look, I can, just a sort of the difference between I just wrote a program and a lot of text scrolled across the screen, and I just wrote a program and I can click on it and I can have animations go. Right there's just, I don't know. I found that to be a very fulfilling, very exciting, very informative learning experience, because just the same way that we're dealing with a client and server now, and you sort of have these two things going on. User interfaces are different from like your public static void main start here and end here, in that instead of saying start here and then just go, it's like, well, display this thing. And then at some point, someone's going to do something with it, and you have to deal with that. I think you'll find that you have to be in a slightly different mindset in terms of at any given point in the code, understanding like what's true or what has happened, because it's not like here again you can't just sort of set a debug point, let your code run for a minute, things stop, and you know exactly where you are. There's more things happening. Working with event-based programming is just a different model than just sort of start and stop. Anyway, we'll see more details of that next week. So this assignment is in some ways is relatively straightforward. It's write a user interface with GWT on your appointment book application. So it should have all the functionality of the previous assignments. You should be able to create an appointment book, enter appointment book, pretty print it. Do that searching, that querying from Project 4. You don't need to write to a file. Just like in Project 4, you don't need to write it to a file. But it should all be done with a web UI instead of a command line program. We'll talk about the entry point and stuff in a minute. You should also have a help menu. That's where your README is, right? No more dash README. Yay, no more command line, right? Anyway, you have a menu now that will give you the README. And that because it's a web application, you do end up talking back to your server, but you don't have to use your you don't need your REST-based client and you don't even have to use your REST API that you developed in Project 4. I suppose it's conceivable that you could, but GWT has other mechanisms that make it easier to pass information back and forth. Error handling. So if something goes wrong, so like you've got bad input, pop up a dialog box. Don't print stuff to standard out, right? This is the web. So use GWT's tools for providing feedback to the user. I encourage you to use your imagination. So this is an opportunity. I don't know if you guys have had much chance to play around with user interfaces, but think of what you might like. Now, this is not. I would recommend against things like developing a completely new user experience frame set where where like everything's like drag and drop or something like that. I will need to be able to figure it out. I think I grade this one, and so then it needs to be intuitive enough so that I can run your project and in like 5 minutes figure out, do some stuff with it and grade it, because there are a lot of you. And so then so be creative, but don't go crazy. Yeah. Okay, so I've put together an archetype, and we'll look at that shortly. Oh, and that's it. I guess do I mention it here? Oh yeah, there's a tool called Balsamic that I like. I think there's still a free version of it, where you can mock up your UI. It lets you sort of do like not stick drawings, but like pencil like drawings and stuff to sort of like lay out your UI sort of like in a little tool to give you an idea. If that helps you develop it, I recommend it. Drawing on a piece of paper is also good. I found that like drawing on a piece of paper, and then you can say, oh well, this thing should be a text box, and you basically map like what you're seeing to the various objects in the GWT API. That's a good way about going about it. So here again, I think the requirements are pretty straightforward. Put a web UI on it. Okay. Before we dive into the archetype, any other questions? You got 3 weeks to do this one, I think. August 10th, yeah. So this is due the last day of class. Same day as the final exam. Okay, let's dive in. Oops. Come on. Stop it, you. Okay. Oh, look, another archetype. So there are even more pieces parts to the GWT project than there were to the web project. It basically has much of the same stuff that the web project has, including something which is a servlet, and then a bunch of client code, but instead of being a command line client code, it is a web UI. So here's the archetype. Sure, go for that. Okay, and then I'm going to open it up in its own project. Oops, no. Open the POM for that. It's going to be a point book GWT. Oops. Okay. So let's look at the stuff. Okay, that's where you're going to want to hit it. Okay, so what the project gives you. Here again, I want to try to. I don't want to go into the details of the code tonight. It takes a long time. I think since most of you haven't started Project 4, I want you to be able to focus on Project 4 for the next week. But what I will show you is what you can do with it. So you run Maven package, and that basically builds the entire application. That'll build that'll build the client side code. It'll build the server side code. It'll package all together into a single WAR file, into a single web application. Oh yeah, so it's doing this GWT compile. Well, so this is the thing that compiles the Java code into JavaScript. And it does different permutations. It's optimized for different browsers, optimized and customized for different browsers. And you've got it all. One of the neat things about GWT is that it's got this mode called called dev mode. There's something called dev mode, and what it does is it runs your GWT application in a way that can be where you can debug the client-side code. So normally in web development, you've got to you can run your server-side Java application in a JVM with debugging enabled, like we saw last week. You can attach a debugger to it. You can debug the server-side code just fine because it's just Java. On the client side, well, luckily browser debuggers have come a long way in the last 5 or 10 years. But 5 or 10 years ago, it was like nigh impossible, and that's how old GWT is. And so what they did is they got this mode where essentially your client code is still accessed in a browser, but you can set debugger points for. That's why I always cross my fingers and hope this works. You can set debugger points in your client-side code, and so you can, because the client-side code during dev mode is really running inside a JVM, and you can debug that too. I guess so. Let me step back again. Remember how I was saying that Google like said, hey, we have all these Java developers that are good at Java. We want them running web applications. Let's let them write web applications in Java. The implication of that and the side effect of that is that you can use all your Java tooling with this. You can use IntelliJ and you can run Java. You can use all of your you can use a lot of your Java APIs on the client side, like some of your collections, like array lists, and all the Java language stuff that you can take advantage of. Strong typing, if that's what you're into. You can also, because you're basically treating your client-side code just like any other Java code. So JavaDoc is there. So all of the unit testing is there. Right up until pretty recently, there weren't good utilities for unit testing JavaScript, and so as a result, people had like all these JavaScript libraries that had no tests associated with it. Right, bad stuff. And so the theory was behind GWT is like, wait a second, we've got all this good practice in Java. Instead of trying to move all that practice to HTML and CSS and JavaScript, let's just keep it in Java. So that's what you've got. Okay, so what I have here out of the box is a very simple application. When you run it in dev mode, what it does is it returns this page, and you've got a button here, and when you click on the button, it pops something up. And what pops up is, it's an appointment book, and it's got some information there. Here in the develop mode console, we've got things like we can say what's being done to the server. So like when I click this thing and it tells me that, I get another entry here in the log. I guess there's only to expand. Back in development mode, let's see here. Oh, this is just sort of telling us what's happening as GWT comes up. To give you you know what? I gotta stop myself because I really want to go into the details, but I really should wait until next time. I guess I'll just leave with the following. So when you're done with development mode, you can just quit out of it, and that stops us. So now if I try to reload, it'll complain because it doesn't exist anymore. That's fine. The other thing that you can do here, I'm going to clean my environment because I'm always worried about it not working. I'm going to run package again, and then I'm going to run Jetty. So just to demonstrate to you that this really is an actual web application and not just a plain old web application with all of this fancy compilation and stuff. I can run the project just as just with plain old Jetty running there, and not that whole development mode thing. It means that I can't debug it. But, oh, actually, wait, it's not exactly Jetty run. This is something that's a little finicky. Jetty run war. Oh, yeah, there's some unit tests. We'll see how to test this code as it goes by. We'll see that there are both unit tests and integration tests. So now my Jetty is running on 8080. So now if I open up this URL, there it is again. If I click it, that will ping the server. And I guess just for yucks, we can look at the page source. Very simple stuff. It says, oh, hey, here's the application inside this JavaScript, and it's all sorts of crazy, highly optimized, compiled JavaScript. But oh, look, we got things called appointment book, and yeah, some other stuff. So if you want, you can look at the source code, but just to demonstrate to you that this is just JavaScript and HTML. Here's the JavaScript and HTML. Okay. Yeah. Any questions on that? Okay. Let's do. Oh, I forgot to go get the keyboards. Anyway, so let me talk about the final kata that will start tonight, and we'll spend some time doing that in the next few minutes. Okay, so our first two katas were pretty straightforward, right? And they were, I guess they were kind of, I call them functional. They like you implemented a function. So like with the word spinner, it's like it was sort of like a straight line. And even with the reverse Polish notation calculator introduced a little bit of state. Right? Everybody uses stack. Well, this final kata will start tonight, and I don't expect people might get through it tonight. I don't know if we do. I don't know what we're doing next week. But we'll start it tonight, and then we'll finish it off next week. This kata implements Conway's Game of Life. Have you guys ever heard of this? It's a sort of well-known computer thingy. So the whole idea is that you've got this little game, and you've got a two-dimensional grid of cells, and each cell represents, well, a thing, an organism that is either alive or dead. There are these rules that govern whether or not a particular cell in this grid is alive or dead. So any live cell with fewer than two neighbors, with fewer neighbors will die. So like underpopulation. So there's only if there are fewer than two neighbors, he doesn't live anymore. Any living cell with more than three neighbors dies because of overcrowding. And then any live cell with two or three neighbors continues to live on to the next generation. And then you've got a dead cell with exactly three live neighbors. It comes back to life, and that becomes live again. And the whole idea is that there are multiple rounds to this game. So you start off with an initial game board, and then every round you evaluate each cell to figure out, well, does it live or does it die? And then it continues on, and what you end up with is like pretty pictures, and you can see that like you'll have like a little spawning ground over here, and then things will things will move out. And anyways, it's kind of neat to watch go by. And so to get us started, like here's an example of what it looks like. So let's say that we have a board that is 4 rows and 8 columns. And let's see here, I think the stars are alive and the dots are dead. So if you start out with this initial configuration, the second generation looks like this because, let's see here, this cell is alive and it's got 2 neighbors that are alive, so it stays alive. Same thing with this cell, these 2 cells down here, they each have 2 neighbors that are alive. But this cell right here has 3 neighbors that are alive, so it's dead and it comes to life. You got it here. And so then, the whole idea that with this kata is that we represent one of these boards, and then you can basically go through the generations, and you can watch the board evolve. Any questions on that? This one will be a little bit more interesting because I think this one offers there's more data involved. I think this one offers the opportunity to do some more object-oriented programming. Because you're actually sort of like, you've got this data. You can imagine what this looks like. You can imagine what the class, well, I hope you can. Imagine what some of the classes, some of the methods might look like and how it all works together. So, any questions before we take it? Do you have one? Yeah.
Should the user be able to specify a starting board?
Yes. And that's the whole idea is that, there is an import starting, there's a starting board, and then that's where it goes. And so like, after each generation, you just print out the board, I guess. Okay, let's break into pairs and mobs. I need to go get the keyboards from upstairs, so it'll be a quick 5-minute break. but probably, or you can just like get started, and then start with the Maven archetype like we did last time.